Good morning, everyone. Uh, we me Vishal Padh and my partner Vijay Pahuja, we are here to present our findings with leveraging AI to reduce technical debt. Uh, to start with, I we would like to present the agenda. Like the agenda for this talk is like discuss about what is the technical debt, the financial burden that it brings with itself, the advantages of remediation of the technical debt, the solution, which is AI versus the traditional tools. We will also highlight some of the tools that are readily available today and the future direction that should that we propose that should be taken. And at the end, we'll be open for some questions and answers. So to begin with, let's start with what is technical debt. I mean, as software professional, everybody has come across the word technical debt. But to put it in perspective, technical debt is the implied cost of work caused by choosing an easy or a limiting solution and to produce it right now instead of using a better approach, which will take a little longer. This is a scenario that most of software engineers encounter in their everyday life, is that the business is asking for some solution like get it done right now. Don't worry if it is perfect or not, if it is performant or not, but get it out to the market right now so that the business starts producing money, which in all due respect is a fair ask. But inadvertently, what happens is that to meet the deadlines and the challenges, most of the software engineers have to take some shortcuts to get there. So that is what in our opinion creates the debt. There are also other ways that the debt would be created, but this is the most prominent way. So when we uh, when we take shortcuts, when we make it quick and dirty is when we accumulate the most debt. So there we have some types defined. We have product feature debt, which is Rust features and scope changes lead to poor UI, incomplete functionality, and user dissatisfaction. The other type is architectural design debt, which is not so very good design or a flawed design decision, which results in unscalable, fragile systems that are difficult to modify. So it will work right now, but if somebody asks you to change it, you will have a hard time. Then the most obvious is the code debt, which is the shortcuts taken by the developers or the poor coding practices, often due to tight deadlines or create a complex, you know, situation, which is like a like a not so very experienced developer is given a very complicated task, sometimes also leads to code debt. This inadvertently makes it very difficult and hard to maintain it in the future and even further it for more development. We also have testing debt, which is insufficient testing coverage. I have seen many code bases in my entire career that have absolutely no testing coverage. And if the code builds and runs, then it is good for production. So that creates a testing debt. Any questions so far? Okay, I'll move on to the next one. Now, the financial burden that comes with the technical debt is really huge. If you look at the chart, it is not a straight line. It is an exponential chart, which means as time goes by, the value loss because of the technical debt increases exponentially. So we have some findings here. As per Stripe's 2018 paper release, they have said that on an average, a general developer spends 13.5 hours a week simply for overcoming or fixing technical debts. which were overlooked before. Also, as per Sonar Source's 2023 paper, it says that the annual cost of a tech debt for a project with 1 million lines of code is roughly around $306,000. And as per CISQ's 2022 paper, the total cost of poor software quality in the US in 2022 itself was $2.41 trillion, which in itself are huge numbers. So goes without saying that controlling tech debt will save us so much of effort and money. Now, as we just saw, that the technical debt has its own costs and issues. These are some of the advantages that the remediation will bring to us. The advantages of remediation are if we are addressing the technical debt in time or in a time which is way before than we normally choose to do so. These are the benefits. So as per the matrix, it says that the time that the developer saves per week is somewhere around 13.5 hours, which we saw in the previous slide. Uh, defect density reduction is about 50 defects per the same code base, which will significantly reduce the amount of revenue loss in production. And also there is another factor, which is the developer productivity, which gains severely because most developers prefer to work on better quality tasks rather than fixing something that was written by somebody else and it previously. So this gives developers a mental boost and they produce better. The there are certain advantages and disadvantages when it comes to the usage of AI tools. Now, what we say is that the AI versus traditional tools is more of a paradigm shift rather than simple tool shift because we were doing something in some way and tomorrow we started doing in some another way is not going to take us there. It's not going to solve the problem. The overall comparison is shown on this slide is the traditional tools versus the AI powered tools. The traditional tools usually rely on fixed and sometimes outdated rules. Like I would give an example here is that the camel casing of the variable names, right? Which is a very good rule to have, but it sticks by it. Whereas what AI is going to do is it is going to continuously learn and understand how things evolve as time goes by, and then it learns from it and understands whether something is a mistake versus it can be ignored. In the traditional tool, we have a lack of business context and analyze code in isolation, which means it strictly follows the rules. If A is not A and it is B, then it fails it. So it's pretty much static. It does not have the context of the whole business picture. Whereas we can train the AI tools to provide context aware and holistic analysis, which is more like the system understands that a given piece of code, what it is trying to achieve, what it is supposed to do, and it will try to find issues in the area of that context rather than in isolation. Prone to false positives, requiring manual review. As I just said, it is pretty much black and white binary that either something is a true or a false, and that's what any traditional tool is going to follow, saying this code does not pass the required rule sets. So somebody has to manually intervene and either fix the rule sets or fix the code to proceed so that the test pass, not the test, rather the reviews pass. Whereas in the AI time, it will offer proactive real-time issue detection, which means it will focus on the core more than the tiny issues. limited scope of complex refactoring, which when we are in a complex situation refactoring things, it might the traditional tools might not understand. Sometimes you have to overlook the rules, whereas the AI power can handle much more complex, and also some more automation is available there. Effectiveness depends on human oversight and test quality, which means it will only give you the shape of the code, whether the variables are named correctly, the alignments are there, and those kind of things are more focused in the traditional tools. Whereas on the AI powered side, you'll get more of a more of a holistic picture, whether your code is functionally fit or not. So these are some of the advantages of using the AI powered tools. On general, we have listed some of the tools available in the market today, which we propose that there could be even more development in this area and this can be bettered further. So there are some tools like CodeRabbit, Kudo, GitHub Copilot, and Bito, which provide review tools, which will review your code. And it is more like a review tool plus plus, which will give you better suggestions based on how you are writing your code and what could be improved in the code perspective. We also have some debugging tools, Chat DBG, Tab9, GitHub Copilot again, Cursor, and Workic AI Debugger. These give you interactive consoles most of the time, which will give you proactive suggestions, recommendations about how a particular task could be achieved, how coding could be changed to fix issues, that kind of stuff. But it mostly helps you in debugging an existing issue. So this is what we see the future as. The future is a partnership. It is not a one or the other. So what we are saying is that AI powered analysis can be used by a human whose expertise and oversight can be used, and a sustainable software system can be achieved. So what we are saying is that fully relying on a human is definitely time consuming and cumbersome, but fully relying on AI is also not there yet. It is not absolutely reliable and sometimes pretty dangerous, because AI depends on the data that it has been provided. So it could and it would make mistakes at this time. So what we are saying is that most of the mundane tasks, repetitive tasks, can be handed over to AI, which it will do very efficiently and powerfully. Those things can be done by AI. A report or an analysis can be produced, which a human can see, and human can intervene if necessary, fix something which AI could overlook, and that gives you more sustainable and a powerful software system with less bugs and less defects, less code debt in production. All right. Here we are. Any questions from anybody?